Hey guys, it's Mrs. Ott here, and I'm here to talk to you about writing the equations of these exponential functions that we've been talking about, given some information, given a word problem. So first, before we really get into the word problems, I want to just remind you of the basic exponential function equation that we follow, and what the different letters represent. So I have f of x equals a times b to the x, and sometimes you'll see this number here in parentheses, same thing. Remember, a is the initial value or the amount you start with, and b is the common ratio. So that's something that you're going to multiply by every time. That's kind of the pattern you see. So we need to keep this equation in mind when we go to write some of our equations later with these word problems we're going to see. So just remember, a is initial value, b is common ratio. So if we look at our first example, we have the Lazy Daisy Duck Farm. Has a total of 52 ducks. They want us to write an exponential function to represent two situations. So the first one is over here, the population of ducks decreases by 13% every year. And then on our second problem, it's kind of two separate ones. They want us to write an equation to represent the population of the ducks increasing by 13% every year. So one we're increasing, one we're decreasing. Remember, keep in mind this is our equation we're going to follow. Remember, this is initial value, and then this is common ratio. I'm just going to abbreviate, but keep that in mind there. So if you notice, we start out with a total of 52 ducks. So in both of my problems here, I'm going to start out with 52 ducks. That's going to be my initial value. That's the amount we're starting with. That's what we initially have. We have 52 ducks. Every year, depending on the situation, it's either going to increase or decrease by 13%, that amount of ducks. So in this first case, it's going to decrease by 13%. So next year, we'll have less than 52 ducks, 13% less. Okay, so we want to represent that in our equation. So that 13%, that's going to be our common ratio, or part of it, in our equation. So right now, if I write my equation, we have a initial value of 52 from up here. So 52 is going to be A. And then B, we're not quite sure yet. We know it has to do with that 13%. And then we still have the X up here and the exponent. So that 13%, we're going down 13% every year. So remember, we like to talk about these percentages in terms of, we're starting with 100% of our ducks. Where are we going from that original 100%? So all 52 of our ducks represent 100% of our ducks. But next year, we're going to go down by 13%. So I'm going to subtract 13% from 100%. And I'm going to end up getting 87%. Now remember, we need to write this as a ratio, and really we need to put this in decimal form is what that means. So 87% is the same as writing 0.87. Okay, all you're going to do, if you're not sure what that is, 87 divided by 100, you could do it that way. Or you could think, I'm just going to move my decimal point over 2 spots, and I get 0.87 that way. So this number is going to be 0.87. We need to turn it into a ratio. 87%, that's a percentage. We can't just put in 87% right there. We have to change it into that decimal, and we'll get our answer. So f of x equals 52 times 0.87 to the x power. Now the second one, very similar, just now we're changing it to increasing by 13%. So we're still starting with 52 ducks. So my equation is going to start out the same, since we still are originally having 52 ducks as our initial value, so A stays the same, but B is going to be a little different. Since we are increasing by 13%, remember, we're going to start off with 100% of our ducks, all 52 this year. But next year, we're going to increase by 13%. So I'm going to add 13 to 100. So that means I'm going to have 113%. Okay, well, when we go to write this into our equation, we need to write it as a ratio. So you can do one of two things. You either take 113 and divide it by 100, or you think, okay, the decimal point's right here. I'm going to move it 2 spots to the right, and I'm going to get 1.13. So this number, the ratio is 1.13, whereas the percentage is 113%. We want to make sure that gets in there as a ratio, not as the percentage. So notice these two equations are very similar. One is decreasing, one is increasing, and that's going to change the ratio, but we're still starting with the same amount of ducks. So just pay attention today specifically on which words they use. You want to locate the initial value. You want to figure out if this is going to be exponential growth or decay. So if we're increasing, that's growth, decreasing, that's decay. And then figure out exactly what ratio you need to put in that equation, either by adding or subtracting from 100. Good luck with the assignment today.